So good day, I'm Julia Marie D. Jaspe, BS Electronics Engineering from Colegio de Muntinlupa. I will be sharing with you the on-the-job training with the company Sinex. I would like to thank the following individuals who made this training possible. Dr. Ruth Aquino, as well as the company Sinex Design Consultancy and Services Incorporated, especially their engineers Ms. Mimi Rolian, Mr. Jesso Espeleta, Mr. Frank Castillo, Mr. Kevin Pineda, Ms. Mary Joyce Malubay, and Ms. Jenica Bartena, who helped us all throughout the training. So first, I will tackle stick diagram. Stick diagram are a means of capturing topography and layer information using simple diagrams. It conveys layer information through color codes or monochrome theme. It also acts as an interface between the symbolic circuit and the actual layout. So on the first week of the training, the first thing we learn is how to make an efficient stick diagram based on the given schematic diagram. The stick diagram will be guide in creating a layout design. It is also easier to understand stick diagram than schematic diagram when creating uh, the layout. So this is the sample of stick diagram that we made during the training. So what is layout design? Layout design is a plan or specification for the construction of an object or system or for the implementation of an activity or process or the result of the plan or specification in the form of prototype, product, or process. So the first activity that we made is inverter. An inverter circuit outputs a voltage representing the opposite logic level to its input. The main function of inverter is to invert the input signal. In this activity, we are asked to do an inverter. We apply the learnings from the Siron manual to lessen the errors and also to be mindful of the minimums of each layer. This layout is known as a simple layout design. It only has a single output and a single input. So this is the basic um, inverter without the bulb. Then we did the inverter with two pulleys and with bulb. So the next activity is NAND. A NAND circuit is a logic gate wherein it produces output which is false only if all its inputs are true. The output of this logic gate complements the logic gate AND. This activity is also categorized as simple layout design. It has two input and a single output. The minimum of each layer is implemented in this activity in preparation to the next activity with three or more inputs to lessen the size of the design. So here's the layout design done. So next activity is AO22. This layout is a combinational. The number of inputs is more than 2, but with a single output also. This will be a stepping stone in making the complex design. So the EO22 layout design that we made have um, 5 inputs and um, single output. So next activity is match. This layout design is almost the same with AO22. The match has 5 input and a single output. In every activity, the layout should be mindful. Uh, the trainee should be mindful of the spaces, widths, enclosures, and overlaps. The next activity is flops. This layout design is considered as complex. The flaps has multiple input and multiple output. Uh, the schematic given is too confusing too, and stick diagram in this layout is done in a day. The layout is also hard because we need to limit the use of metal to metal sheet. So here is the routing is too hard uh, because we need to be to compress it within the size um of the layout. Next is activities of amp. The layout of amp consists of current mirrors and differential pair. This also needs uh, two dummies in each current mirrors and differential pair. Also, it needed to minimize the spaces within the design. So the skills learned during the training uh, can create an efficient stick diagram, can do basic layout design, can create a compressed layout, good communication, teamwork, and willingness to learn.